So for dimension, for UPS, there's no calculation. So nak tak nak dia akan tanya about definition and some of the basic concept. But for PSPM, there's no definition punya question. Memang tak ada definition punya question. So bear in mind lah. Okay, so dimension you need to know about definition, and then you need to apply lah. Okay, you need to be able to determine the dimension of derived quantities, and then another one is verify the homogeneity of equation using dimensional analysis. So the main thing is that number one, you need to be able to determine the unit. Okay, determine the and another one, you need to determine the homogeneity. Okay, the first part tu actually kamu dah belajar kat sekolah. Cuma contohnya kamu belajar dulu, kamu cari unit. Sebagai contoh lah, what is the unit for velocity? Who can tell me what is the unit for velocity?
Meter per second.
Meter per second, yes, exactly. So dekat sekolah dulu, kadang-kadang kan kamu buat lah macam VMS sama dengan S over T, right? It's a delta S over delta T. So when you try to determine the unit dekat school dulu, masa saya sekolah dulu, masa kamu saya tak sure. Kamu ada buat macam ni, dan kamu ada buat macam ni. Ada tak buat macam ni?
Ada.
Ada kan? So this
Ada,
one is actually, okay, good. This one is actually the dimensional punya analysis. Ini adalah part of it. Tapi masa kat sekolah dulu kita skip. Step tu dekat belakang lagi sebenarnya. Okay, for your syllabus, first thing you need to determine dia punya dimension punya symbol. So this is the important part lah yang kamu kena tunjuk dekat exam kamu. So S is actually your displacement, right? So displacement measure quantity apa? Faham tak soalan saya?
Apa ya?
Apa dia
Measurement, sorry, displacement tu dia ukur apa sebenarnya?
Length kan?
Length, okay, exactly. Quantity yang dia ukur adalah length. Length simbol dia apa?
L.
L.
Yes. So quantity length, the symbol is capital L, betul? Ada bracket ke tak ada bracket?
Tak.
Tak.
Tak ada Ada lah.
Ada.
Bracket tu
Ada
memang
kan?
nak kena letak ke sih?
Kan dekat
Okay.
line
Apa dia?
Kan dekat
Unit.
yang tulisan length.
dekat tulisan length tu yang ada bracket.
Oh ya, bila L tu dah tak ada
Dekat L tu dah tak ada.
Okay, kamu ikut nota kan? Okay, so saya ikut kamu lah. Okay, bukan apa sebab dia every year sometimes dia berubah-ubah. Kadang-kadang tahun ni macam ni, tahun depan macam tu, tak apa, kita samakan lah. So S is actually your length. So if you write in terms of quantities like that, ada bracket. Okay, below here is your time. Ada bracket. Okay, we're going to bring this one a little bit further down. So time, the symbol is, simbol time apa?
A.
Apa?
T besar.
T besar. Okay. So ini untuk simbol untuk dimension tu. Bukannya simbol untuk formula, the symbol untuk dimension. So you can replace this one, becomes L over T. So then you determine what is the unit for L and what is the unit for T. So SI unit So unit, ayo. For L is in meter and T is in second. So that's why you came out with M/S. Okay, so dekat sekolah biasanya kamu skip yang this part. Kan? You simply came out with this one. So
Yes.
jadi dekat sekolah kamu apply dimension analysis tanpa disedari. But this one for your syllabus is very important. You have to write it down lah dalam exam. Okay. Ada bracket, tak ada bracket. Saya nak cakap ada satu tahun tu saya pernah tanda dia kata dia sangat particular. Okay, you have to put square bracket. If you put curve bracket dia salah, dia katalah. Padahal ada certain years, okay tak apa. Yang penting jawapan akhir. So it depends on the time of the year lah. So for me personally, my advice is that kita try to fix lah. So kita ikut benda ni. So you have the main, dekat YouTube lah. You have the main quantities here. Okay. And then you replace it with the formulas. And then you replace it with the dimension. Okay. This part is the dimension analysis. Yang tengah ni. Okay. So basically this syllabus is about this one. Hasilnya is the unit ni. Kadang-kadang dalam exam dia suruh cari unit ni. Tapi most of the time dia suruh cari sampai sini je. Okay. Remember And then kalau dia suruh cari unit, let's say if the question asks you to find the unit for velocity using dimensional analysis, make sure you do this step. You show this step. Walaupun dia simple. Okay. Okay, so your task, I want you guys to refer to your lecture notes. Try to find how many quantities that you have. Ada berapa banyak quantity lagi yang saya tak tulis kat sini? Ada berapa sebenarnya? Ada table dia dalam tu?
Ada.
Ada. Okay, kalau ada, nanti kamu cari and then kamu completekan yang bawah ni. So this one, ada lagi and so on. So that one is about 1.1. Dimensional analysis. Okay, the second part is homogeneity of equation. So the main reason why you do the homogeneity of equation is basically you want to determine whether an equation is correct or not lah. Basically whether it's correct or not. Tapi kita panggil homogeneity. So the other part is non-homogeneity. Kamu pakai term ni kan? Non kan? So an equation is considered homogeneity ataupun homogeneous when the left hand side punya dimension is equals to right hand side punya dimension. So basically when you try to do the dimensional analysis, you end up on the left hand side, contohnya yang tadi tu kamu dapat L over T. No bracket, sorry. You got L over T. And then on the right hand side, you get L over T. So this means that this one is homogeneous lah. Left hand side is equal to right hand side. Okay, tapi ingat saya tak suka kamu tulis equal macam ni. Nanti kat tutorial saya tekankan lah. Saya padam kat sini. So biasanya I will ask my student to do left hand side like this. Macam kat sekolah juga. So kira kamu dapat L over T. Dan right hand side, you kira you dapat L over T. So ini example bila dia homogeneous. Kamu okey tak ni? Kamu senyap ni? Agak merisau.
Okay, sir.
Okay, example for non-homogeneous. The left hand side, so I'm going to write this one maybe in blue color. The left hand side is not equal to the right hand side. Okay. So example, when you try to do the dimensional analysis, you end up with left hand side, LHS ni left hand side is equals to L over T. But then when you try to do the right hand side, you get L over T squared. So it's different. So it's not the same. The dimension is not the same. So therefore, you can conclude that the equation is non-homogeneous. So itu je. Tak ada apa pun, senang je chapter 1. Okay. Okay, so going back to the learning outcome, going back here, so 1.3, they wouldn't ask in PSPM lah, sebab this one is amali. Yeah. 1.2, you guys will apply it throughout the semester. Okay, this one adalah pengetahuan yang kamu akan apply untuk satu semester. So this one, apply. Okay, when I said you have to apply throughout the semester, that means dia tak ada direct question. Okay, dia tadi kata soalan satu, okay, find the vector, tak ada. But then you have to apply vector ni dekat satu semester. And semester 1 memang kamu pakai most of the quantities is a vector. Okay, jadi kita pergilah. So, dalam exam, soalan satu, PSPM, dia mesti akan tanya dimension. Okay, so there's no way kamu boleh escape dimension analysis ni. Maka ada sikit je, 2 kot tak salah saya. Dia sebenarnya 1 point something je maka dia. Tapi dia round off, maka dia jadi 2 kat final. So, jangan hilang maka 2 ni. It's very simple things. Dah confirm dia akan tanya dimension tu. So, tak masalah lah. Okay. Now, we go to the second subtopic. Walaupun dia tak tanya dalam exam, this is basically penentu kamu dapat A ke tak dapat A dekat semester 1. Kenapa saya cakap penentu tak penentu? Sebab most of the quantities ada vectors untuk semester 1. And for those yang memang tak faham vektor daripada awal, daripada sampai akhir semester, biasanya dia punya exam memang sangkut. Okay. So this is really important. Saya tekankan, sangat penting. Tapi tak adalah susah pun nak difahami. So as long as you guys do enough exercise, should be okay. So the first part ni, chapter 1, try to do a lot of exercise in scalar and vector. Dia punya definition, dia punya tu tak penting sangat pun. Tak penting. I mean, as long as you know, okay lah. Kita pergi definition dulu. Okay, so who can tell me what is the difference between scalar and vector quantities? Apa beza scalar and vector quantities?
Scalar magnitude je.
Okay, scalar
magnitude dan
So vector dia ada magnitude and direction.
Yes, exactly. So this one is the thing that you learn in school kan. So sepatutnya tak ada masalah kot. So ada siapa-siapa yang tak faham tak magnitude tu apa? Okay, magnitude tu dia punya macam mana dia benda tu macam bahasa mudahnya maybe kita boleh cakap magnitude tu kuasa dia lah. Berapa banyak, berapa nilai dia. Okay, contohnya I push a box to the right. Okay, contoh let's say if I have a box lying on the floor and I basically applied some force and I push it to the right with a force. So the question is how much strength you put to push the box. So the quantity would be 5 Newton. Okay, the 5 Newton is the magnitude. So where did I push the box? I push it to the right. Kamu nampak kanan juga kan? Okay. So when I push it to the right, that means this one is my vector. This is my direction. Okay. So in a way, force is actually a vector quantity. It has a magnitude and it has a direction. Okay. So I give you one example already lah. So what is the example of scalar quantity? Mass.
Distance.
Yes. Okay. So kalau biasanya lah kalau orang cakap distance, partner dia apa?
Displacement.
Yes, displacement. So, okay, distance and displacement, you guys will learn about the definition in chapter 2. Nanti kamu belajar lah apa beza distance and displacement. But for now, distance is a scalar quantity, displacement is a vector quantity. Displacement ada direction, distance tak ada direction. Dia macam satu tu berapa jauh kau dah jalan, satu tu kau jalan ke mana. Macam tu lah. Tak tahu membantu ke tak perumpamaan sebegitu. Okay, so the main thing about this one, so I'm gonna focus on the vector sebab saya cakap lah vector tu ada banyak ni lah kamu punya calculation. So kita ada satu step what we call a resolving vector. And then you have another one which is called resultant vector. Okay, resolve by its name kita pecahkan. Resultant kita gabungkan. Itu bahasa mudahnya lah, bahasa pasarnya. So let's say if I have a vector in this direction, katakan vector saya ke sini, this is my force contohnya. Kalau saya nak resolve, basically saya pecahkan dia, pecahkan ke mana? I have to pecahkan dia kepada X and Y component. Okay. Kalau resultant vector, basically saya gabungkan. So this is the opposite of resolving. So basically, initially I have all the Fy net in this direction, all my Fx net in that direction. So the resultant vectors is this one. Okay. So this is what we call F net. Sometimes resultant lah. F total sama je maksud dia, tak ada beza pun. Okay, kenapa kamu kena buat resolving? Kenapa kamu kena buat resultant? Masa bila kamu kena buat? Okay, so saya tanya, saya jawab. You have to do resolving and resultant when you have to find addition or subtraction of a vector. So kamu ada beberapa vectors, kamu nak tambah ataupun nak tolak. So, saya tulis je lah. Resolving or resultant. Okay, when you try add or subtract vector. Okay. Okay, saya kasih contoh. Let's say if I have a box. Contoh paling mudah lah, kita pakai force ya. And then somebody push this box to the right, and somebody push this box to the left, to the right jugalah. Okay, the first force F1 is equals to 3 Newton. Okay, F2 is equals to 5 Newton. Contohnya. So the resultant force would be berapa?
8.
8. Okay, senang je lah. So F net is equals to 3 plus 5, which is equals to 8 Newton. So apa yang kamu buat sekarang ni is basically you add vector. You add two vector lah. If my F2, katakan F2 ni is in opposite direction, So by right, I will have to minus the vector. Betul? Subtract lah. So this is what I meant by adding or subtracting. Tapi dekat sini kalau kamu tengok, bila saya buat, adakah saya resolve? Adakah saya pecahkan?
Tak.
Tak kan?
Tak.
Saya simply add kan? So basically it's the act of finding the resultant vectors. Okay? So masa bila kita kena resolve? Okay, kita kena resolve bila let's say I have the same box. Okay. But now my force is in this direction and in this direction. So this one is still my 5 Newton F2, but the difference now my F1 is in that direction. Okay. If you can see clearly, the F1 is not on the x-axis or in the y-axis. Dia bukan dekat atas x ataupun dekat atas y. So I'm going to take this one. Let's say draw a new one lah. So I'm going to draw the vectors only. So this one is what we call the free body diagram, which what you will learn in chapter 4. You have two force, that one and this one. This one is what we call F2. And this one is my F1, which is equals to 2 Newton. Sorry, 3 Newton. Okay. Okay, sekarang ni boleh tak saya tambah 5 tambah 3?
Tak.
Kenapa tak boleh?
Tak.
Arah lain.
Arah dia lain-lain.
Sebab
betul?
arah dia lain.
Betul? So you guys faham masa bila kamu kena resolve. So the reason why you have to resolve is because you cannot simply add the two vectors. Kamu dah tak possible dah nak tambah vector-vector ni. So basically you have to do something lah. So you have to resolve. So when you try to resolve, basically you have to change to x and y component. So this would be my x-axis. So this is my x-axis and this is my y-axis. Okay, so F1 is not located on X or Y. Dia seorang dia yang kat tengah-tengah tu. So, kamu kena pecahkan lah. So, ulang banyak kali pecahkan. So, this one bila kamu pecahkan, then you will have F1X and F2X. Faham? Okay, good. So, let's see if I put a theta over there. Then my F1X would be equals to
F1 cos theta.
okay, F1 cos theta. F2X equals to F1
theta.
sin theta. Okay, macam mana saya hafal dulu daripada sekolah sampai sekarang? Cikgu sekolah saya ajar cara nak hafal. Kalau kamu punya theta tu ada dekat sini, that means yang dekat dengan dia tu, sebelah dia tu ada theta, itu adalah cos. This one, sebelah dia tu tak ada theta. So the theta is on the other side. So that means that one is S. Itu yang saya hafal lah daripada sekolah sampai sekarang saya apply. Tak ada masalah. You can ikut cara kamu lah nak hafal macam mana. So daripada mana datang benda ni sebenarnya? Dia datang daripada trigonometric punya triangle. So senang je. Katakan saya ignore yang F2 tu dulu. I just focus on F1. So if I were to redraw, this is my F1. This would be my F1X. And this would be my F2X. Okay. Sorry, ni F1 maafkan saya. Okay, so basically ini yang kamu buat, kamu resolve tadi tu. Daripada mana datang sin dan cos tu? Let's say if I bring this one to this side, okay, so this one becomes a triangle. Kan, tadi dekat tepi tu saya alihkan dia ke sini, jadi a complete triangle. So if I have a theta over here, which I do have, so cos theta is equals to adjacent over hypotenuse. So katua kan, kamu hafal kan?
Apa sir?
And then kalau sin becomes opposite, which is F1y over F1. So if I rearrange, if I bring this one up here, then I get this one. Okay, ini datang dia. So benda ni you don't have to do it every single time. Ini sebab introduction saya tunjuk lah. But then bila calculation, bila dalam physics, the important thing is this part and this one. Tapi konsep daripada mana dia datang tu, you still need to understand lah. Kalau kamu pusing-pusing soalan, kamu terus tak faham. Okay, so your task now is that I want you to do the remaining, I want you guys to read the lecture notes kalau kamu belum. Tadi saya ada suruh kamu asingkan, buatkan table ni kan. Mana tadi? Table ni, can you complete this table? Okay, and then I will give you some exercise on vectors and dimension lah. Saya kasih sedikit exercise, a simple one. Okay, so after this you can do. Okay, exercise tu buat je dulu sebab kita still tak ada Google Classroom. Sebab saya sebenarnya nak tunggu dulu. Biasa saya buat after a week, tapi maybe this week saya akan buat lah. Okay, saya nak tunggu student settle down dulu. Nanti dia keluar masuk, dia pening. Okay, anyway, any question?
Tak ada.
So far so good, sir.
Okay. Tavin, okay? Aminah? Okay. Jauh Aminah dekat angkasa kan. Okay, if you guys don't have any question, I think we can stop here now. Okay. Okay, recording ni biasanya saya akan nak stop. Okay. Recording ni nanti saya akan upload dekat YouTube saya. Nanti saya kasih kamu link YouTube tu. In case kamu nak tengok, boleh tengok lah. So that you guys always have the backup lah kalau kamu terkeluar termasuk ke. I know the feelings bila kamu tengah belajar terkeluar termasuk tu. Dia memang kacau kita punya mood. So saya letak je in case kamu nak tengok bila-bila masa. Okay. Thank you everyone. I see you guys next time, which is bila next time kita jumpa? So tomorrow evening. Betul Pukul 2 esok kita jumpa. And then try to do the tutorial question because tomorrow kita dah start discuss tutorial question lah. Nanti saya minta kamu tunjuk kamu buat apa. Okay. Faham? Kamu present tau. Nanti saya alright, bye-bye.
Faham, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Assalamualaikum.
Thank you, sir.
Thank you, sir.